Today we'll be discussing the agent mesh, AI cloud architecture. Subscribe to the channel and like this video for more great cloud tips. The agent mesh belongs to the distributed systems side of AI cloud architecture. It's an architecture where specialized AI agents discover each other, communicate, and collaborate through standardized protocols. Those agents span teams, accounts, and cloud providers. So what does that actually look like? Picture a network of cooperating specialists instead of one large model doing every job. Multi-agent systems, or MAS, is the field this pattern grows out of. A single agent holding 50 tools degrades fast. Its context fills with instructions it doesn't need. Splitting the work gives each agent a narrow toolset, a smaller prompt, and a clearer evaluation target. Designing for it changes what you build. You're defining contracts between agents rather than function calls. You get independent deployment and scaling, plus every failure mode a distributed system carries. Agent discovery is how one agent learns that another exists and what it can do. The A2A protocol publishes an agent card. It describes an agent's skills, endpoints, and authentication. Agent marketplaces and registries hold those descriptions the way a service catalog holds APIs. Managed options are appearing on all three clouds: Amazon Bedrock Agent Core, Azure AI Foundry, and Google Gemini Enterprise Agent Platform. By the way, this was previously done by Google Vertex. Bedrock Agent Core Gateway is now a managed entry point for MCP tools, A2A traffic, and multi-model routing behind one secure endpoint. Treat your registry as production infrastructure. A stale entry routes work to an agent that no longer answers. Communication protocols are what keep a mesh from turning into custom glue code. Model Context Protocol, or MCP, connects an agent downward to tools, data sources, and context. Agent-to-agent protocols, written A2A, connect agents sideways to each other as peers. A2A carries tasks, streaming updates, and artifacts over HTTP. It moved to the Linux Foundation in 2025. MCP later landed under the Linux Foundation Agentic AI Foundation, or AAIF. Founding support came from Anthropic, OpenAI, Block, and the major clouds. So both agent-to-tool and agent-to-agent standards now sit in neutral open governance. Use MCP for capability and A2A for collaboration, and you won't rebuild either one badly. Orchestrator agents, often called supervisor agents, decompose a goal and route the subtasks. Specialized worker agents do the narrow work. Think querying a warehouse, drafting code, or checking compliance. Which topology should you pick? Hierarchical versus peer-to-peer is the topology decision underneath that split. A hierarchy is predictable and easy to audit, but the supervisor becomes a bottleneck. Peer-to-peer meshes absorb scale and partial failure better. Their behavior is harder to predict. Most production systems land between the two, with a shallow hierarchy whose leaves talk directly. K-Agent, a Kubernetes native open-source framework, is one concrete mesh stack. Agents and MCP tool servers are declared as cluster resources, with native A2A between them. Shared context and memory stops 5 agents from solving the same subproblem 5 times. They need a common store for task state, intermediate results, and prior decisions. Think pgvector on Postgres, Redis, or Azure Cosmos DB. Distributed coordination handles the right side. It decides who owns a task and who may update it. Leases, idempotency keys, and an event log on Kafka do most of that work. Don't pass whole conversation histories between agents. Context windows and token bills both punish you. Dynamic team formation means the set of agents on a job is chosen at runtime. An orchestrator reads the request, queries the registry, and assembles the agents whose skills match. A refund dispute might pull in policy, payments, and customer history agents. Why does that need a rule? Conflict resolution matters the moment 2 of them return incompatible answers. You need an explicit rule, a ranking agent, a confidence threshold, a vote, or escalation to a person. Leaving it implicit means the last writer wins, which is a coin flip dressed up as a decision. Trust and reputation between agents asks whether you should believe what an agent just told you. Start with cryptographic identity using SPIFFE and Spire or your provider's workload identity. Then every agent proves who it is, then score behavior over time, success rate, latency, and how often others reject its output. Policy propagation carries authorization and data handling rules along the whole call chain. An agent acting for you must never gain permissions you don't have. Pass scoped, short-lived credentials. Open Policy Agent and Cedar keep those rules outside the prompt. Solo's agent gateway patterns wire CEL, OPA, and OpenFGA style checks onto MCP and agent core fronts. Identity and authorization travel with the call, not only inside the model prompt. Learn more at systemsarchitect.io. Like and subscribe to the channel and follow the playlist. A service mesh for agents borrows what already works for microservices. Istio, Linkerd, and Envoy give you mutual TLS, retries, timeouts, and circuit breaking for free. Agent Gateway sits in front of that stack as an AI-aware gateway for MCP, A2A, and LLM traffic. Its policy and observability aim at agent calls rather than plain HTTP APIs. Failure handling and resilience is harder here. An agent fails by being wrong as often as by being down. Budget every task in tokens, seconds, and retries before it runs. Observability across agents ties it together. Open telemetry traces follow one request through 6 agents. Cross-cloud agent collaboration is the payoff. Protocol-level contracts let an agent on Azure call one on Google Cloud. Extensibility is the clearest gain because adding a capability means registering an agent rather than redeploying a monolith. Reliability improves when a failing specialist degrades one skill instead of the whole assistant. What happens to the bill? Costs drop as well, since you can route cheap subtasks to small models and reserve frontier models for the hard steps. Operations gets easier too. Per agent traces and success rates show you which specialist regressed. Skip the mesh when one well-equipped agent can already do the job. Emergent behavior control is the reason. Agents that talk to each other produce loops, runaway spending, and outcomes nobody specified. Cap recursion depth, fan out, and total spend per task before you ever need those limits. A deterministic workflow beats a mesh whenever the steps are known. Reach for AWS step functions, Azure durable functions, or temporal instead. Latency is the other cost, because every hop adds a full model round trip. The agent mesh turns multi-agent systems into infrastructure, where supervisors and specialized workers discover each other through registries and collaborate over MCP and A2A. Community consensus in 2026 is consistent. MCP is agent to tool, A2AI is agent to agent, and production meshes still need a separate layer for shared state, tracing, and spend limits. Making that safe takes shared memory, distributed coordination, and conflict resolution. It also takes agent identity and reputation, propagated policy, and mesh-level resilience and tracing across clouds. Reach for it when your capabilities are many and evolving. Stay with a single agent or a deterministic workflow when they aren't. Thanks for checking this out. Hope you learned something. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.